Why do onions make you cry? Why does sticky tape smell strange? Why do your ears pop on airplanes? Why do bubbles glow like rainbows? And why does ice float when almost everything else sinks? None of these are accidents. They're clues to how physics and chemistry quietly run your everyday life. Let's start with one that's made millions of people cry. We've all been there, haven't we? Standing confidently in the kitchen with a sharp knife in hand, ready to conquer that seemingly innocent onion, only to be dramatically defeated by a sudden flood of uncontrollable tears just moments later. It's a universal struggle for home cooks everywhere, but have you ever stopped to wonder why this humble, everyday vegetable packs such a surprisingly powerful, tear-inducing punch on our eyes? Today, we're going to peel back the layers of this intriguing mystery, dive deep into the fascinating science behind those watery eyes, and share some clever, practical tricks to help you keep the tears completely at bay while you chop.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
It all begins the moment you cut into an onion. You're not just slicing through a simple vegetable. You're actually breaking open thousands of its tiny cells, which function like miniature chemical factories waiting to activate. Hidden inside these cells are two key players: unique sulfur compounds that give onions their bold, distinctive flavor and pungent aroma, and a special enzyme known as alliinase, just poised for action. As soon as the cell walls rupture from your knife, these two components mix together instantly, sparking a rapid and efficient chemical reaction right there on your cutting board. This clever reaction produces a brand new compound called synpropanethyl S-oxide, a highly volatile sulfur-based gas that escapes quickly into the air around you. Since this gas is much lighter than the surrounding air, it effortlessly wafts upward from your cutting board and heads straight for your unsuspecting eyes, no escape in sight. Upon reaching the thin layer of water in your eyes, the synpropanethyl S-oxide swiftly transforms into a mild form of sulfuric acid, creating that stinging sensation. Your eyes, detecting this unfamiliar irritant immediately, kick into full defense mode by producing a rush of tears to flush out and wash away the perceived threat effectively. While it's a smart, natural protective reflex designed by evolution, it can be incredibly inconvenient and frustrating when you're just trying to whip up a delicious, flavorful meal in your own kitchen. So, how can we outsmart this sneaky, tear-jerking vegetable once and for all? Let's jump into some practical, easy-to-try tips along with a few surprising fun facts to arm you for battle. First tip, try chilling your onions beforehand. A cold temperature significantly slows down the enzyme activity, resulting in much less of that pesky tear-inducing gas being released during chopping. Simply pop your onion in the fridge for about 30 minutes or into the freezer for just 15 minutes right before you start chopping to give yourself that chill advantage. Another effective trick is to cut your onions under a steady stream of running water or position yourself near a strong, reliable fan to disrupt the gas flow. The flowing water effectively dissolves those troublesome sulfuric compounds before they can rise, while the fan briskly blows the lingering gas away from your face and eyes entirely. Many professional chefs swear by using a very sharp knife for onion chopping, a razor-sharp blade causes far less damage to the cells, releasing fewer irritants into the air overall. This is the perfect excuse to finally sharpen those dull knives lurking in your kitchen drawer and keep your tools in top condition for better results every time. Did you know that not all onions are created equal? Different types produce varying amounts of that infamous tear-inducing compound based on their sulfur content. Sweeter varieties like the dahlias contain notably less sulfur, making them far less likely to bring on the waterworks compared to their sharper counterparts. If you're especially sensitive to onion tears, make a point to opt for these sweeter varieties whenever they're available at your local market or grocery store. Here's a fascinating fun fact: that tear-inducing compound in onions is actually an evolutionary defense mechanism developed over time. It evolved specifically to deter hungry pests and wild animals from munching on onions in their natural growing environment, protecting the plant effectively. And for a truly surprising twist that many swear by, some people claim chewing gum while cutting onions can surprisingly help prevent those tears from flowing. The theory suggests that chewing gum promotes more mouth breathing, which somehow diverts the irritating gas away from your sensitive nasal passages and eyes effectively. Although not backed by rigorous science yet, it's a harmless, fun experiment worth trying next time you're dicing up onions in your kitchen. So, the next time you find yourself tearing up over an onion, remember it's simply a clever, natural chemical reaction at work, not some personal vendetta against you. Armed with these handy tips, you can now minimize the tears dramatically and maximize the incredible flavor onions bring to all your favorite home-cooked dishes. Which of these tear-saving tricks will you be eager to try first in your own kitchen? Feel free to share your own favorite onion cutting hacks and tips in the comments below. We'd love to hear them. And don't forget to hit that subscribe button for more fun, bite-sized culinary insights, surprising science facts, and practical kitchen tips delivered right to you.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.
Have you ever noticed that distinct, almost chemical smell when you peel off a piece of sticky tape? It's a common experience, yet few people stop to wonder why. This isn't just any ordinary scent. It's a fascinating byproduct of physics and chemistry happening right before your nose. Today, we're diving into the secret science behind that peculiar aroma.
Behind every question lies discovery. I'm Seluna, and this is SciCurious, where we uncover the science shaping our world.
At its core, sticky tape works through two main principles: adhesion and cohesion. Adhesion is the attraction between the tape's adhesive and the surface it's sticking to. Cohesion, on the other hand, is the internal strength of the adhesive itself, holding its own molecules together. Both are crucial for tape to do its job effectively. When you peel tape, you're essentially breaking these adhesive bonds. This action generates friction, which in turn creates a phenomenon known as triboluminescence. Triboluminescence is the emission of light resulting from the breaking of bonds in a material when it's subjected to mechanical stress, like tearing or peeling. But what about the smell? That's where the chemistry comes in. The adhesive layer of most tapes is made from long chains of polymer molecules. When you peel the tape, the mechanical stress not only causes light emission, but also breaks some of these polymer chains. This process is called mechanochemical degradation. These broken polymer fragments are often volatile organic compounds, or VCs. They're small enough to become airborne and reach your nose, creating that distinctive smell. The exact scent can vary depending on the specific type of adhesive used. For instance, acrylic-based adhesives, common in many household tapes, produce a different bouquet than rubber-based ones. Some researchers have even described the smell as a mix of burnt plastic or electrical discharge, which makes sense given the energy released during peeling. It's a tiny, localized chemical reaction happening right under your nose, a testament to the complex interactions at the molecular level that we often take for granted. Did you know that the intensity of the smell and the light can depend on how fast you peel the tape? Faster peeling often leads to more pronounced effects. This is because a quicker separation applies more sudden stress, breaking more bonds simultaneously and releasing a greater burst of energy and VCs. You can even try this at home. In a completely dark room, slowly peel a roll of clear tape. You might see faint blue or green flashes of light. Then try peeling it faster. The flashes should become more noticeable. It's a simple yet powerful demonstration of triboluminescence. The specific polymers used in tape adhesives are often synthetic rubbers or acrylics, chosen for their flexibility, durability, and, of course, stickiness. These long-chain molecules are designed to be viscoelastic, meaning they exhibit properties of both viscous liquids and elastic solids, allowing them to flow and deform while maintaining their structure. When these chains break, they don't just disappear. They form new, smaller molecules that are often more volatile, contributing to the unique scent profile. It's a delicate balance. The adhesive needs to be strong enough to stick, but also flexible enough to peel without leaving too much residue or tearing. This balance is achieved through careful engineering of the polymer structure and the addition of various tackifiers and plasticizers. Now for a fun twist. Did you know that triboluminescence isn't just for tape? It's been observed in everything from crushing wintergreen lifesavers to peeling pressure-sensitive labels. In fact, some scientists have even explored using triboluminescence as a way to generate electricity or as a sensor for mechanical stress in materials. Imagine a future where your packaging tape could tell you if a package has been mishandled just by emitting a tiny flash of light. The science of sticky tape is far more intricate than simply holding things together. It's a microscopic world of breaking bonds, light emissions, and volatile compounds. So the next time you reach for a roll of tape, take a moment to appreciate the hidden scientific spectacle unfolding in your hands. That peculiar smell is a tiny, aromatic whisper from the molecular world, reminding us that even the most mundane objects hold extraordinary secrets. It's a perfect example of how science is all around us, even in the everyday items we use without a second thought. From the light it emits to the scent it releases, sticky tape is a miniature laboratory of physics and chemistry. If you enjoyed uncovering the mysteries of sticky tape, don't forget to like this video and subscribe for more fascinating scientific explorations.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.
Ever wondered why your ears suddenly feel like they're stuffed with cotton when a plane takes off or lands? It's a common, sometimes uncomfortable, sensation many travelers experience. This isn't just a quirky travel inconvenience, it's a mini physics mystery playing out right inside your head. Let's unpack the science behind this phenomenon.
Behind every question lies discovery. I'm Seluna, and this is SciCurious, where we uncover the science shaping our world.
Our journey begins with air pressure. At sea level, the air around us exerts a certain amount of pressure. As an airplane ascends, the atmospheric pressure outside the cabin rapidly decreases. Inside your ear, specifically in the middle ear, there's a small, air-filled space behind your eardrum. This space is usually at the same pressure as the outside world. When the plane changes altitude, the air pressure outside your body changes quickly. However, the air inside your middle ear doesn't always catch up right away. This creates an imbalance, higher pressure inside your middle ear compared to the lower pressure outside. This pressure difference makes your eardrum bend outwards, like it's being pushed. This bending or stretching of the eardrum is what causes that uncomfortable feeling of fullness, muffled hearing, or even mild pain. And guess what? That's the sensation we commonly call ear popping. But don't worry, your body has a clever, built-in tool to handle this, the eustachian tube. Think of it as your ear's personal pressure regulator. This small tube connects your middle ear to the back of your throat, allowing air to flow in and out. It's usually closed, but it opens briefly when you perform certain actions. Every time you swallow, yawn, or chew gum, the muscles in your throat activate, causing that little tube to open. This allows air to flow in or out of your middle ear. When the eustachian tube opens, it equalizes the pressure between your middle ear and the outside environment. Boom, pressure equalized, and your ears pop back to normal. So, chewing gum on a plane isn't just for fresh breath or to pass the time. It's your secret weapon against pressure discomfort, constantly stimulating those muscles to open your eustachian tubes. And yawning dramatically might make you look a little weird to your seamates, but hey, it's science in action. It's one of the most effective ways to open those tubes wide. Other tricks include sipping water, which encourages swallowing, or trying the Valsalva maneuver, gently blowing air out while holding your nose and keeping your mouth closed. During descent, the pressure changes can be even more rapid and pronounced than during ascent. This is often when people experience the most intense ear-popping sensations. This is also why babies often cry on planes, especially during landing. Their eustachian tubes are smaller and more horizontal, making pressure equalization harder for them. Pro tip for parents: Feeding a baby or giving them a pacifier during takeoff and landing helps them swallow frequently, which in turn helps to equalize that pressure. Did you know that not only airplanes, but even elevators in very tall buildings can cause your ears to pop? The rapid change in altitude, even if it's just a few hundred feet, can be enough. Also, scuba divers experience similar pressure changes, but in reverse. As they descend, water pressure increases, and they must actively equalize the pressure in their ears to avoid injury. So, the physics of pressure equalization is a universal concept, whether you're soaring through the sky or diving deep into the ocean. It's all about balancing forces. To sum it up, ear popping happens because of pressure differences around your eardrum, caused by rapid changes in altitude. And your built-in equalizer, the eustachian tube, saves the day by opening to balance that pressure. Just chew, yawn, swallow, or try the Valsalva maneuver. These are your easy physics hacks to keep your ears happy and comfortable. So next time your ears pop mid-flight, don't panic. It's just physics saying hello at 30,000 feet, and now you know exactly why. Understanding these simple scientific principles can make your travel experience much more enjoyable and less mysterious. Follow and subscribe for more mini physics lessons on the go, and discover the science behind everyday phenomena.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.
Have you ever wondered why soap bubbles, those delicate, fleeting spheres of shimmering magic that float so gracefully, always dazzle us with their vibrant array of rainbow colors dancing across their surfaces? It's not merely a trick of the light, oh no. It's a truly fascinating phenomenon grounded in the wonders of physics, where ordinary soap and water mixture turns into a breathtaking, ever-changing light show right before our eyes.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
At the heart of every soap bubble lies an incredibly thin film of soapy water that stretches out delicately, trapping a small pocket of air inside its spherical form. This soap film is astonishingly thin, typically just a few millionths of a millimeter in thickness. Yes, thinner than the finest strand of a human hair by a huge margin. The real secret behind their eye-catching vibrant colors is revealed in the intricate ways that light waves interact with these ultra-thin layers of liquid. When everyday white light, containing every color of the rainbow from red to violet, strikes a bubble's surface, a portion of it bounces right off the outer layer. But wait, here's the really cool part. Another portion of that light ventures deeper, passes through the outer layer, and then reflects back from the inner surface of the soap film. These two reflected light waves, one from the front surface and one from the back, now travel together and interfere with each other in predictable yet magical patterns. This captivating process is known as thin film interference, and it's the precise mechanism that produces the bubble's signature dazzling display of swirling colors. The exact thickness of the soap film at any spot, combined with the angle from which you observe it, determines which colors will destructively cancel out or constructively reinforce to shine brightly. Whenever waves of the same color reinforce each other perfectly, those colors appear much brighter and more intense, giving us the vivid rainbow hues that we all love to watch. As time passes and the water within the bubble's film slowly evaporates, the film becomes progressively thinner, which causes the colors to dramatically change and shift in mesmerizing ways. Finally, when the film thins out to an extreme degree where it can no longer hold together, the entire bubble reaches its dramatic finale and pops spectacularly. That's precisely why soap bubbles keep changing their colors constantly, right up until their very last, beautiful moment in existence. Importantly, the thickness of the film isn't perfectly uniform all over the bubble. Gravity steadily pulls the heavier water downward, leaving the top noticeably thinner than the bottom. This natural variation in thickness across the bubble's surface explains why you typically observe a beautiful spectrum of different colors in various parts of the same bubble. The angle at which light strikes the bubble also plays a crucial starring role. If you circle around a bubble or change your viewpoint, you'll see the colors shift dramatically. This happens because your new perspective alters the precise path length that the light waves travel, which in turn modifies the interference pattern and the resulting colors. So, the very next time you find yourself mesmerized by a soap bubble's enchanting beauty, remember that you're actually witnessing a tiny, dynamic, and perfectly natural physics experiment unfolding live. Remarkably, even the simplest soap bubble we can make at home serves as a perfect classroom to teach us profound lessons about complex wave phenomena and the intricate nature of light itself. Beyond their undeniable aesthetic beauty, soap films like these are actively studied across numerous scientific fields, including material science, optics, and fluid dynamics. Through these studies, they help scientists deeply understand how ultra-thin layers behave, interact with light, and respond to forces in their surrounding environment. This same thin film interference principle appears everywhere, from the delicate, iridescent structure of a butterfly's wing to the sophisticated anti-reflective coatings applied to high-end camera lenses. Indeed, it's a fundamental scientific principle that elegantly explains so many of the vibrant, rainbow-like colors we encounter daily in both nature and cutting-edge technology. Therefore, the next time you or a child blows a soap bubble into the air, pause for a moment to truly appreciate the incredible, hidden science powering its short-lived yet colorful existence. Every single bubble is essentially a tiny, temporary masterpiece crafted from light, physics, and a bit of soap, a delightful reminder of all the scientific wonders hiding right in plain sight around us. Ultimately, this simple childhood joy beautifully connects us all to some of the most fundamental and timeless principles of science in the universe. We truly hope you enjoyed this fun and colorful journey deep into the weird and wonderful science behind those mesmerizing soap bubbles. If you're feeling curious and eager to learn more about the amazing scientific world all around us, be sure to check out and explore our other fascinating topics and videos.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.
Ever noticed how ice cubes just chill at the top of your drink instead of sinking? It's a common sight, but have you ever stopped to wonder why? Most solids, when placed in their liquid form, will sink. Think about a metal block in molten metal, or even a rock in water. This is because, typically, solids are denser than their liquid counterparts. The particles are packed more tightly together, making the solid heavier for its size. But water? Water is a true anomaly, a scientific marvel that defies this common rule in a spectacular way.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
The secret lies in its molecular structure, specifically how water molecules behave when they transition from a liquid to a solid state. When water freezes, its H2O molecules don't just huddle closer, they actually arrange themselves into a very specific, open, crystal lattice structure. Imagine it like a neatly organized honeycomb or a tiny, intricate scaffold. This arrangement is quite spacious, creating more empty space between the molecules. Because of this unique structure, the water molecules in ice are actually farther apart than they are in liquid water, even though they are fixed in place. This increased spacing means that for the same amount of mass, ice takes up more volume than liquid water. In simpler terms, ice is less dense than water. And according to Archimedes' principle, anything less dense than the fluid it's in will float. That's the fundamental reason behind ice's buoyancy. This quirk of water is far more than just a fun fact for your iced beverages. It's a critical property that has profound implications for life on Earth. Imagine a world where ice sank. Lakes and oceans would freeze from the bottom up, crushing aquatic life and altering ecosystems dramatically. Instead, because ice floats, it forms an insulating layer on the surface of bodies of water. This layer protects the water below from freezing solid. This allows fish, plants, and other aquatic organisms to survive through harsh winters, thriving in the unfrozen water beneath the icy shield. Without this unique property, life as we know it, especially in colder climates, would be vastly different if it could exist at all. It's a delicate balance, maintained by the simple yet profound behavior of water molecules. But water's weirdness doesn't stop there. Did you know that water is one of the only substances that exists naturally in all three states, solid, liquid, and gas, within Earth's normal temperature range? This versatility is crucial for our planet's climate and weather systems, constantly cycling between forms. Another fascinating fact, water has an incredibly high specific heat capacity. This means it takes a lot of energy to raise its temperature. This property helps regulate Earth's climate, preventing extreme temperature fluctuations and making our planet habitable. So, the next time you're enjoying a refreshing drink with floating ice, take a moment to appreciate the incredible physics at play. Without floating ice, our lakes would freeze solid from the bottom up, and the very foundation of aquatic life would be jeopardized. It's a tiny molecular quirk with giant consequences, ensuring the survival of countless species and maintaining the delicate balance of our planet. To recap, ice floats because water expands when it freezes, creating a less dense structure due to its unique hexagonal molecular arrangement. This tiny molecular quirk has giant, life-sustaining consequences for Earth's ecosystems and climate. It's a testament to the intricate and often surprising wonders of the natural world. Stay curious and keep exploring the amazing science all around us.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.